So the price at which company A is willing to buy shares of stock in your business is modeled by the function B of t, where t is the time of day and is measured in hours since the stock market opens. The true price of a share of stock in your company, in other words, the amount you know each share to be worth, is modeled by the function P of t, where P of t is the true worth of a single share of stock in dollars, and t is measured in the number of hours since the stock market opened. The stock market opens at 8 a.m. and closes at 4 p.m. You have the ability to buy as many shares at the true price as you want and then instantly sell them to company A. At what time will you be able to make the most money doing this? So there's a lot going on here, but what we want to boil it down to is what allows us to make money. So thinking about this situation, we know that at any time we can instantly buy a share of stock at price given by P of t and then instantly sell it to company A, who's willing to spend the amount given by the function B of t. So how much money am I making? Well, it depends how much more company A is going to buy the stock for compared to the amount that I had to pay for it. So in other words, I want to think about my profit. I guess I can just write it out here. Think about my profit as being equal to the difference in how much they're willing to spend, B of t, minus the amount I had to pay, P of t. And so I'll actually just be able to compute that because I can use I can combine the functions by subtracting. So B minus P of t is what I'm looking for. And when I actually do that, I will take my function B of t, negative 0.7 t squared, plus 3.2 t, plus 42.7, and I'm going to subtract all of P of t. And this is where I've got to be a little careful in how I do the subtraction. So I'm going to subtract, and remember I keep that in parentheses, I'm subtracting the whole value of P, not just part of it. 0.5t minus 0.5 square root of t plus 43.5. So I distribute the negative sign inside, which means I'm going to be subtracting, adding, and subtracting. And so I can now combine these like terms. There's no squared term that I'm subtracting, so I still have negative 0.7t squared. I have a 3.2t, and I'm subtracting, I have negative 0.5t, so that's going to give me 2.7t. Then I have 42.7 minus 43.5, and I would be thinking that that's the last thing I've got, but notice that I also have this plus 0.5 square root of t, so that combines with nothing because I have no other square root of t anywhere, and then at the very end I'm going to take this 42.7 and subtract 43.5 from it, which will give me negative 0.8. So that's going to be my function, the profit function, and I want to know when I can make the most profit. So in other words, where is the maximum value of this function? And you might think to yourself, let me just use the quadratic formula or manipulate this quadratic in a way that I can find the maximum value. Negative b over 2a would be the t value where that occurs. But that's not going to work because this is a square root of t, and so it would not exactly be a quadratic function. So we'll need to use a calculator or Wolfram Alpha to find the maximum value. And it's important, you can do this on your own, maybe using Wolfram Alpha, that you're looking for t values in between what? So we know that we're working between 8 a.m. and 4 p.m., and t is the number of hours since the stock market opened. So at 8 a.m. my t value is 0. So I'm going for anything between, so t greater than or equal to 0, but less than or equal to, it closes at 4 p.m. And so that would be 8 hours after. So some t value in between 0 and 8 so that it's in the time when the stock market is open.